This is section 1.6, prerequisite review for more equations and applications. We will factor by grouping. We will find the restricted value of a rational expression. We will find the least common denominator. We will define these two exponential expressions, and then we will convert between rational exponents and radical notation. So lots to do. Let's begin by factoring with grouping. So what we do here is we go ahead and we group the first two terms together and the second two terms together. And what we do is we see what they have in common. So between an 8 and a 4, there's a 4. And between an a squared and an a, there's an a. And they have nothing else in common. So now if you divide 8a squared by 4a, you get 2a. And likewise, you'll get a negative b. Okay, and you can check this. You can go ahead and multiply this. 4a times 2a is 8a squared minus 4a times b, which is a 4ab. So if you do need to go back and check any of these, feel free to do so. Sometimes it just makes it a little bit easier. Okay, so what we have in common in these next two terms is we can go ahead and factor a 3 out and a c. And what's left is a 2a minus b. Now, what do you notice? You should notice that we have a common factor between these two terms. So if we would factor that out of both of those two terms, we would be left with 4a plus 3c. And that is how we factor by grouping. Let's go ahead and take a look at number 2. So we will group first 2 and second 2 together. The first two have an x in common, and we factor that out. We get a y minus c. The second two terms have a 7 in common, and we factor out a y minus z. Again, we have a common factor in both terms. So if we factor that y minus z out, we're left with an x plus 7. Let's give number 3 a try. First two terms, second two terms. And we have a 5 and an a in common and an a plus 6. We'll take a negative 2 out and we'll have an a plus 6. So if you need to check this, go ahead. Negative 2a minus 12. Now, as you can see, we have those two terms in common. So now we will factor an a plus 6 out, and we're left with a 5a minus 2. Looking at number 4, we will take a look at each of these two terms first. And we have just a p in common, and we're left with 2p minus 1. And here I can just take a negative out, and I have 2p minus 1. Now we have a common factor between those two terms. So if I factor a 2p minus 1, I get a p minus 1. And you could go ahead and say you're factoring a 1 out of there if you'd like. Sometimes it's easier to see it like that. And really, we are factoring a negative 1 out of there. Okay? Okay. Now let's go on to objective number 2, restricted values. Keep in mind that the denominator cannot be equal to 0. So looking at this right here, k cannot be equal to -2. H cannot be equal to what? What if h were a number and you subtracted 4? You guessed it. H cannot be a positive 4. I'm going to show you how to do that though. So how did I get that? I set k plus 2 equals to 0. I subtracted 2 from both sides. And I know that k equal to -2 makes the denominator equal to 0. So that is why I restricted the denominator. So k equal to -2 is a restriction. How did I come up with h not equal to 4? I said h minus 4 equals 0. I add 4 to both sides, and h equals 4. And h equal to 4 makes the denominator equal to 0, so h equal to 4 is the restriction. Now, taking a look at number 7, keep in mind that what we did on these other two, we set the denominator equal to 0, and we end up with x squared equals -9. So we take x equal to plus or minus the square root of the other side, and that is not possible. So we cannot take the square root of a negative number. That's not a real number. So no restrictions. I think I'd like to erase this. Yeah. Okay. Let's go ahead and look at objective 3. So for the least common denominator, we will look at the denominator for each one of these rational expressions. But first, we have to factor this. So we create an x and we multiply 1 times, let me highlight that, a 1 times a positive 2, and we write that here as a 2, and then we have a -3 here, and we write that here. So we're looking for two numbers that multiply together to add up to 2, to multiply together to equal to 2, and add up to a -3. So, of course, we have a -2 times a -1 is equal to 2, and a -2 minus 1 is equal to -3. Then, what we do after that is whatever this is written here, so a 1w, and then we try to reduce it, and we have a -1 over w. Whoops. And then we have w minus 1 times w minus 2. And that's what number 8's denominator is. So what I think I might do is I might move this real quick, and I'm going to move this down and this down. So that you can see that this is its denominator, okay? Right here. And then the other denominator, of course, is a difference of squares. So if that's something that you need to take a look at, that's w plus 2 multiplied by w minus 2. So those are our two denominators. And so we will look at what they have in common. and they both have a W minus 2. So the LCD, we just write it one time if they have it in common, but we still need a W minus 1 and a W plus 2. So if they have it in common, you will only write it one time. That factor in common. Okay, let's try the same thing for number 9. And in number 9, we have a little factoring to do. So this is an 8 with a 3y plus 1. So if we factor that 8 out, and here we can factor a 6 out. So these are our two denominators, and as you can see, we have a 3y plus 1 in common. So that LCD, we would just write 3y plus 1 down once. And then what do you know? A 6 is a 3 times 2, and an 8 is a 4 times 2. So they do have a 2 in common, so we only write that 2 down once, and then of course we write a 4 and a 3. So now what we have in common is 2 times 4 times 3 is 24, so we have 24 3y plus 1. So 24 times 3y plus 1. And that is our LCD. So again, if they have a common factor, we only write it down once in the LCD. Okay, objective number 4. The definition of these two exponential expressions. Okay, let me tell you that this right here is equal to the nth root of a. And this right here is the nth root of a to the m. So whenever you have a, it's raised to the power over root. Power over root. Okay, let's practice this. 144 is raised to the first power over a square root. Now keep in mind, we don't write that 2. But that is the root, and of course that answer is 12. Let's take a look at number 11. Power over root. So we have 243 to the third power, and then we have the fifth root of 243. Now, let me just get this here. What we can do here, so we don't have to cube 243, we could go ahead and take the fifth root of 243, and when we're all finished, we can cube that. So let's go ahead and take the fifth root of 243. So 243 raised to the 1/5 power. And that is 3. And then 3 cubed, of course, is equal to 27. And there's lots of ways you can do this. You could have said the fifth root of 243. And so you can go to the math menu and you can go to number 5. And you can say the fifth root of 243, like that. So either way. Okay, let's go ahead and do that in number 12. We have power over root. So I think the most important thing is to first consider the negative exponent. So we want to rewrite without the negative exponent, if you have one. So this exponent right there, we don't want. So we could go ahead and say 1 over 81 to the 3/2 power. And that makes that exponent now positive. Okay, so let's keep going. This is 1 over 81 has a power of 3 and it's a square root. And we just talked about being able to go ahead and take the square root of 81, and then when we're all finished, we will cube it. And that is 1/9 cubed, and now we have, I don't know why I write so big. And then, of course, when we cube that, we have 729, 9 cubed. And you can check that in your calculator. And so how you would do that is you would say 9 and then use the caret and then the cube. Okay? So that is 1 over 729. Okay, now this time we don't have a negative root. So here we have power over root. So we have the cube root of -8. And the cube root of -8 is -2. Since -2 times -2 times -2 is a -8. Okay. Now we're going to convert. We've done some of this already. Now we're going to convert each expression to radical notation. Okay? See if I can move this pen over here. It does not want to come over here. There we go. Okay, so remember this is power over root. Power divided by root. So here we have the cube root of q squared, okay? Power over root. Here we have the 5th root of t cubed, okay? Now be careful because only y is raised to this power. So this is equal to 6 times the 4th root of y cubed. Make sure you don't include 6. It does not have a parenthesis around it, okay? So it's really important that you note that that's 6 times the 4th root of y cubed, okay? Now we're going to go the other way, okay? Power over root. So here our root is 3 and our power of our variable is 1. So x to the power over root. So it's x equal to the 1/3. Let's do that here. Our root is 3 and our power on y is 2. Remember, power over root. So we have y to the 2/3 power. So I hope that this section helped you.